But when you want to divide two like bases, you want to use the quotient rule. To divide like bases with exponents, keep the base and subtract the exponent in the denominator from the exponent in the numerator. So when I tell you to subtract the exponents, this is what I mean. M minus n, you're finding the difference by subtracting the exponent in the denominator from the exponent in the numerator. So if we had x to the fifth divided by x to the third, we keep the base, x, and we subtract the exponents, 5 minus 3, which gives us 2. If the exponent in the denominator were negative, that does not change the process. You are still subtracting the negative. So x to the fifth divided by x to the negative third is equal to x to the fifth minus negative 3. When you subtract a negative, it's the same as adding them. So 5 plus 3 equals 8. Let's have a look at an example with coefficients and multiple variables. What you would do, step 1, divide the coefficients. So these are like terms, if you will. 20 divided by 4 is equal to 5. Then step 2, you divide the like terms by subtracting the exponents. So you divide the x term by an x term only. X to the ninth divided by x to the third is equal to x to the 9 minus 3, which is 6. You divide your y's. Y to the 7th divided by y to the 5th is equal to y to the 7th minus 5, which is 2. And then you have z to the 3rd and no z in the denominator. So that just leaves you with z to the 3rd in the numerator. So that gives you a final answer of 5 times x to the 6th times y squared times z cubed. So to utilize the quotient rule, when you are dividing monomials, you divide the coefficients and then you divide only the like terms. Let's have you do a few practice questions. Find the quotient. Question number 1, x to the 4th, y to the 10th, divided by x to the 3rd, y to the 12th. Question number 2, 12, x to the 8th, y to the 4th, z to the negative 2, divided by 4, x to the negative 2, y, z to the negative 4th. Question number 3, 20, x to the 6th, y to the negative 1 times z, divided by 5, y squared, x, z cubed. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1, divide the like terms by subtracting the exponents. So you're going to divide x by x. So we have x to the 4th divided by x to the 3rd. When we subtract the 3 from the 4, we get x to the 4 minus 3, which is 1. So that's just x. You divide your y term by the other y term. Y to the 10th divided by y to the 12th is equal to y to the 10th minus 12, which is negative 2. So we have a negative exponent, so we'd like to make that positive. So step 2, move each term with the negative exponent to the opposite side of the fraction line. And then step 3, make the exponent positive. So we move the y to the negative 2 to the denominator, and that gives us a final answer of x over y squared. Question number 2, step 1, divide the coefficients. So 12 divided by 4 equals 3. Step 2, divide the like terms by subtracting the exponents. So you're going to divide your x by the x term, your y by the y, and the z by the z. So starting with the x's, x to the 8th divided by x to the negative 2. You subtract negative 2 from 8. So x to the 8th minus negative 2 is 8 plus 2, which is 10. Our y terms, y to the 4th divided by y. Since it's just y, the exponent is 1. So we get y to the 4 minus 1, which is 3. Then lastly, our z terms. Z to the negative 2 divided by z to the negative 4 is z to the negative 2 minus negative 4, which is plus 4. So we get positive 2 for z, giving us a final answer of 3x to the 10th, y to the 3rd, z squared for question number 2. Then lastly, question number 3. We were given 20x to the 6th, y to the negative 1z over 5y squared x z cubed. You want to organize your variables in the same order, so when you're dividing the like terms, it's a bit easier. When you're multiplying these terms, it does not matter what order they are in. So if you are given a term in the denominator where the variables are not in the same order, just reorganize them so that they line up with the top. Whole number over whole number, x over x, y over y, z over z, and all of our exponents are the same. And now you can proceed. So step 1, divide the coefficients. 20 divided by 5 is equal to 4. Step 2, divide the like terms by subtracting the exponents. X to the 6 divided by x is equal to x to the 6 minus 1, which is 5. Y to the negative 1 divided by y squared is equal to y to the negative 1 minus 2, which gives you negative 3. And then z divided by z cubed is z to the 1 minus 3, which is negative 2. So we have 4x to the 5th, y to the negative 3, z to the negative 2. So step 3, move each term with a negative exponent to the opposite side of the fraction line. And then step 4, make the exponents positive. So we're going to move our y and z terms from the numerator to the denominator and make their exponents positive, giving us a final answer of 4x to the 5th over y cubed z squared.